Hello ladies and gentlemen, this is the artist Moth. I just thought I'll do this as I'm really interested in the convection currents of the planet that we stand on. So as you can see here, the white mass in the middle, that represents our core, and if you get really close, if you can see all that moving, that is what happens in our mantle. It moves around, that creates even more heat, and the water around represents basically our crust. And if I am correct, I'm not going to stick my finger in because there's soap in there, and soap will drive the temperature of the water up to insane temperatures, but the surface of the water will be a lot cooler than the where the soap lies. And when this was boiling, look at that, it's going anti-clockwise because there's some heat being pushed up into the bowl. What is happening is, can you see all that moving? All that moving. Look, all this. All this right here. It's turning clockwise. So, what this means is that the thicker the substance, if you have a really thick substance, like soap or anything like that in your bowl, water and things like that, you can try this and it will do some really weird stuff. But at the end of the day, what this shows is that the Earth's core and mantle, they work together to create convectional heat. So as you can see here, around here, right here, can you see that little loop there? And there's a little loop here. Those are convectional loops, and we get those inside stars, inside planets, even inside moons, for example Ganymede. Like inside, for example, Jupiter, and also there's another loop here. There's a big one here. Inside a gas giant, convectional currents are different because it's hydrogen, helium, and but also lithium, potassium, and other metals. They all create. Oh, look at this massive loop. So what this means is that convectional loops are essential for a planetary's core to function. So if you don't have convectional loops, the planet's core will freeze because it's not able to push that heat up and draw more cooler semi-molten iron and nickel and potassium and cobalt and things like that, metals down into the inner part of the mantle. And what we can see here is that it is starting to spin. And it's starting to spin because there's more and more heat being pushed up into the bottom of the bowl. So because there's syrup, or as in this science experiment, core, it's able to trap a lot more heat. So the same thing happens with our core. The inner core of our planet makes the heat, so it pushes the heat up, and the outer core, for example here, the syrup, it gets superheated, so it reaches tens of thousands of degrees hotter than the surface of our sun, nearly as hot as the what we call as the convection zone of our sun. And so the as you can, that if you see right here, that is moving because the heat drives the mantle. So the mantle is here. This is the mantle, right? And the surface of the water is crust. So think of the surface of the water as the crust. Just under the surface of the water, that's the mantle. The mantle is being heated by the syrup, because syrup can boil at much higher temperatures. And this really does kind of give us, it shows us that if our planet doesn't have convection currents, so if I turn the heat off, over time the convection currents will die down. If too much heat, and I'm not going to do it, but if I put it right up to 6, over time, it will, the water or the mantle will become hotter than the core, and that will stop the core as well. So it's really important to have convectional currents, but also having convectional loops. And the loops on the sun, on the surface of the sun, those are created by the convectional loops inside the convection current of, or the convection zone of the sun. So we have a large loop here, right here, and then we have another one here. And it's really interesting to watch. To anybody who loves science and astrology and planets, things like that. But I've been wanting to do this for days, weeks really, and I wasn't able to find a substance thick enough. And then my mother got black syrup. Black syrup is actually thicker than normal syrup. So black syrup is really, it really shows you that if you think of the black syrup as like the thicker magma in the inner and outer core, and then you've got the much more dense but more runnier magma on the outer mantle and just under the crust. It really shows us that it doesn't depend on how heavy a liquid is, but it also depends on the temperature. So the hotter, like for example, hotter water will actually sink down to the bottom, and cooler water will be pushed up to the top. And this is the same thing that's happening right here. Is the cooler water is being pushed violently up to the top, and the black syrup, the really sticky syrup, is being, well, pushed down to the bottom by the pressure of the water. And what this does is the syrup just, it absorbs the heat, and over time it absorbs more and more heat until eventually you start getting these loops all around, but also it starts to spin. So you would start to see like a spinning motion, and sometimes it might change direction, or it might do some wacky stuff. But this is really a very similar thing that happens inside our planet. So if we were able to cut the Earth open in half, we would see a very similar thing, except it will be incredibly bright and like 10,000 times hotter. But oh, you see this? This is a filament. This is a convectional filament right here. It's not a complete loop, but you can see that it is starting. Look at that! Look at this! Look at this right here! Look at that! That is a completely. That is a convectional loop, and this here is a convectional filament. Now, this is practically the same thing what we would see inside a terrestrial planet. It will be a slightly different inside a gas giant, because it's can be from 1,000 to 10,000 times hotter than inside a terrestrial planet. sometimes very large gas giants, their cores can be as hot as it's starting to spin now, so there's more and more heat being pumped in, and this is just, I've never known it to actually do this until now, but because the syrup represents the extremely thick molten iron and nickel and potassium and cobalt and all the really heavy metals inside our core, because the inner part is a lot hotter. I reckon it's about 3 times hotter than the outer part of the syrup. So the heat is being pushed outwards, and as it's pushed outwards, the outer part of the syrup is actually it expands, so it bloats in size. So really, this was only half the size, about the size of my thumb like this, and it's just bloated in size. And that is really, it doesn't really happen like that in a planet. It stays the same size, but the mantle, the atoms of the melted material that makes the magma actually bloats in size. It grows. So that's why magma is somewhat, if you get like solid cobalt and then melted cobalt, the melted cobalt will be lighter than the solid cobalt because the atoms have actually grew in size because of the intense heat. The same thing is happening right here. So this is bloated in size. It's grown in size, and you will get some of this. It will start to like have like filaments and loops and God knows what. But over time, these loops will go back in. As you can see here, they'll start to sink back in because they'll cool down. And this is just this is amazing, and this just really help. I think this will help a lot of people understand that the Earth's core, or the inner part of the Earth, is so much more complicated than we think it is. It's practically similar to the surface of the sun, where you get all those filaments and loops and magnetic discharges and things like that. You get all this inside the planet, so it's just it's really insane. And if you do this and it first goes anti-clockwise, do not worry, because it will reset itself and then it will start going clockwise. But then it may go back to anti-clockwise. I'm not entirely sure why it does that. I think it may have something to do with the magnetic field of the planet, but also I think it has something to do with the moon as well, because the moon tugs on the Earth. So we don't we don't feel the moon, but I don't think it's just the moon. I think it's also temperature fluctuation. So the Earth's core, it doesn't stay at a same temperature. It fluctuates, so it cools down slightly, and then it heats up, and then it cools down and heats up. That is really what triggers all these super volcanoes to explode. So, like, for example, when Mount Toba went off, I don't know when, I think it was like 3,000 years ago or something like that, the year without a summer, that was caused by an increase in the Earth's core temperature. And then when you had, for example, when Yellowstone went off the last time, that was also caused by an increase in the Earth's inner temperature. But right now, I think we are probably entering one of these global temperature increases. But it does take a long time for these massive massive temperature increases to happen. So I reckon that it's been at work for probably a good 250 years. The increase in the Earth's core. So I mean, it's nothing really to worry about. But this really does. This will help us, so many scientists and astrologists and geologists, to understand how the planet works. This is so simple, but yet it will help so much. I appreciate you guys watching. I hope that you guys can comment, like, subscribe. You can even share this video if you want. Also, it's a bit shaky. I'm sorry if it is a bit shaky. Because my mother is holding her phone recording. But I really do hope that you like this video, and I would love to hear your comments, because this will help science so much. This will help us understand how a planet works inside. You got a massive filament coming off the syrup core, as I'm going to call it now, and you got a loop rising. You got a loop, and that loop just broke because it was not thick enough. But you got another one, and another one. It's coming off. It comes off in waves, and this is amazing. So anyway, I hope that you like this video. Subscribe if you want, but I just, this blows my mind, and you guys are wonderful for watching this, for watching my videos. And if you want to see this, if you want to see a video like this again, or if you want to see a blog or something like that, please say, because I will be happy enough to make a blog. Thank you for watching. This is the Artist Moth signing out.